solving log equations without using a calculator. I love it when we don't have to use a calculator because I just feel like using the calculator just takes extra time sometimes, right? Thing to remember, you can't take the log of a negative number, okay? So you need to watch out for that. You may end up with some extraneous solutions. Now you might be saying to yourself, why can't I take the log of a negative number? Great question. Let's do a quick review. Why can't I take the log of a negative number? Say I wanted the log base 2 of negative 4, and we want to figure out, well, what does that equal? Well, when you think about converting it, we would be saying 2 to what power equals negative 4? Well, you can't take a positive number and multiply it by itself any number of times to end up with a negative answer. Okay, so that is why there are no logs of negative numbers, okay? Because no matter what that negative number is, you're always going to run into that issue. Okay, so that is the piece that we are keeping in mind as we work here. Okay, so having that, here's our property we're going off of, okay? Log base b of x equals log base b of y, then x has to equal y. And again, I find this kind of an obvious property, right? If I tell you that the log base 2 of x is equal to the log base 2 of 12, and I ask you what x is, isn't it obviously 12? You have to put a 12 there to make it equal log base 2 of 12, right? So that's the only property that we're looking at here. All right, so we're going to use that property, but not with all of these problems. So let's start with this guy, because that is going to use that property. Oh, no, I take it back. It's not. We'll come back to that property in a minute. It's going to be a nice one. Okay, so let's start by taking a look at these guys. So first thing you want to check for is just, can you convert it and solve, right? I'm going to try to just convert this into exponent form and see where it gets me. So little number becomes the big number. Outside number wants a friend. Stuff in the middle wants to be left alone. Hey, look, I can solve that. 2 to the third is 8. Subtract from both sides. X is 5. Done. Well, that was lovely. Now this guy here, I was thinking that I was going to use this property, but then I noticed they have different base numbers, right? And this property, the base number has to be the same. So that was my tip off that we can't use that property. So I'm looking for another way out instead. And that's where I noticed this guy. Log base 4 of 16. Well, I can just simplify that, right? So log base 4 of 16, 4 to what power equals 16? 2. Right? So that simplifies to just 2. So I have log base 2 of x minus 5 equals 2. And now just like the last one, I'm going to convert it. So 2 squared equals x minus 5. So x minus 5 equals 4. X is 9. Lovely. All right, this guy here. Ooh, so this one is a little bit weird. We have sort of nested logs. So what I'm going to do is I'm going to start on the inside and see if I can simplify this guy. So log base 9 of 3, right? So log base 9 of 3. So I'm thinking to myself, what is this going to equal? So 9 to what power is 3? Well, 3 is the square root of 9, right? So 9 to the 1/2 power is 3. So this is the same as log base x of 1/2 equals -1. Okay, and then let's try converting it and see where we end up. This one's a little bit different because the variable's in a different spot, but let's see where we get, right? So it's going to be x to the -1 power equals 1/2. And hey, I can solve that. That's pretty easy, right? So what number to the -1 power is 1/2? 2, right? 1/2 is just 2 flipped. So there we go. Great. Okay, let's take a look at this next one. All right, so this one, we got a couple of logs going on here, and I'm looking at this and I'm saying, log base 6 of 3, 6 to what power equals 3? That's not going to work. But these guys have the same base, so I am going to use my product property to combine these back together. So I'm going to take this 2, bring it up on the x, and then I'm going to combine these two logs together. So it's going to be log base 6 of 3x squared equals 2. And now I can convert and solve. So I'm going to get 6 squared equals 3x squared. That's 36. And I'm going to divide both sides by 3. So 36 divided by 3 is 12. And then I'm going to square root both sides. So I'm going to get positive and negative, and that's going to simplify to 2 square root of 3. Okay, but now, right, anytime I'm getting a negative answer, that's always like, ooh, hey, is that extraneous? I better check, right? If I plug in negative 2 times the square root of 3 here, I'm going to end up with a log of a negative number, which is a problem. Okay, so this guy right here, that's extraneous. All right, and our only answer is positive 2 root 3. Okay, you do always need to check because sometimes it'll be okay, but sometimes it won't. Okay, so you got to watch out for that. All right, cool. Next guy, this one. So same deal here. I've got these 2 logs. I'm going to combine them together into one big log. Subtraction. So I'm going to make it log base 2 of x plus 3 divided by x minus 2 equals 3. Okay, convert that. I'm going to get 2 to the 3rd power equals x plus 3 over x minus 2. All right, and now I want to solve this. So I'm going to multiply both sides of this equation by x minus 2 to clear out my fraction. And that's going to be an 8, right? So I'm going to go ahead and distribute as I kind of do this. So it's going to be 8x minus 16 equals x plus 3. So 2 to the 3rd was 8. And then I multiplied both sides by x minus 2. So 8 times x minus 2, that's where that came from. Cool, and then I've got a pretty easy solve from there. So 19 over 7 would be my final answer. Okay, next guy. All right, so this guy, I've got a couple of logs. Again, I can't simplify that to a whole number, right? 4 to what power equals 10, that's not gonna happen. So what I'm gonna kind of do is I'm gonna rearrange this a little bit to get these logs on the same side so I can combine them together like we just did. Okay, so I'm going to, actually, I think I'm going to bring this guy over here and then bring the 3 over there just to keep things positive. So it's going to be log base 4 of x minus log base 4 of 10 equals positive 3. Okay, because I wanted to keep that 3 positive. It really doesn't matter. You could have gone ahead and subtracted this log from both sides and had it equal to negative 3. Not a big deal. So then this is log base 4 of x over 10. And now I can convert. 4 to the 3rd power equals x over 10. 4 to the 3rd power is 64. And then when I multiply it by 10, it's going to be 640. All right, this guy down here. So this one I have 2 logs. And the difference here between this guy and the ones before it is that here I only have 2 logs. This one I had 2 logs and also another number, right? 2 logs and also another number. 2 logs, also another number. Just 2 logs, okay? So when it's just the 2 logs, that's where this property comes into play. If they have the same base number and they equal each other, then the arguments have to equal each other. So this guy here, same base number. So that tells me that the 2 arguments have to equal each other. So x plus 5 must equal 2x minus 4. Okay, and then I can go ahead and solve that, and I'm going to get x equals 9. Okay, I just did a quick little check and make sure I'm going to get something positive for both of those, which I am, so that's cool. All right, this guy, I've got 3 logs. So what I'm going to do is I'm going to combine these guys together. They're all the same base number. So I'm going to go ahead and combine those together and make this log base 2 of 5x equals log base 2 of 15. And now I've just got 1 log on each side, same base number. So 5x has to equal 15. And there we go. So it's kind of really nice when that happens. Okay, next guy, right? 3 logs. And again, I'm kind of just checking, are there any of these that I can convert into regular numbers? No, that's my best bet, but log base 4 of 8, That's not just going to equal some whole number. So that's not going to work. But I can combine these two together. So I'm going to make this log base 4 of x squared minus 2x equals log base 4 of 8, which means that x squared minus 2x must equal 8. And look, it's our good friend, the quadratic. So can I factor it? Two things that multiply to negative 8 and add to negative 2. Negative 4 and positive 2, right? So my two solutions are going to be 4 and negative 2. And then a quick check. The 4 I'm good with. It's going to make both of those positive. Negative 2 is going to make at least one of them negative. So this guy is extraneous. So my only answer is x equals 4. And again, that's not always true. Just because you get a negative answer does not necessarily mean that it's extraneous. Sometimes they are and sometimes they aren't. You always have to check. All right, this guy, all log base 10. So I'm going to go ahead and combine these guys together, and it's going to be log of x plus 2 over x equals log of 10. So then x plus 2 over x equals 10. So x plus 2 equals 10x. And then we've got a pretty easy solve from there. Okay, side note though on this one, I did it out this way, but log of 10, this is by default a base 10, right? So what I could have also done for this problem is I could have said, well, on this side, I'll combine them to the x plus 2 over x. But on this side, the log base 10 of 10 is just 1. Right? And then from there, when I convert, little number becomes a big number. That's a 10 by default. So it'd be 10 to the first equals x plus 2 over 10. And you end up in the same spot. So you could have done that one either way. All right, last one. Okay, so let's push through this guy, and then we will call it a day. So I've got lots of logs here. Some of them have different base numbers from others, right? So these two are both log base 2. These two are both log base 10, okay? I don't have anything that I can just straight out simplify. So what I'm going to do is I'm going to rearrange this and put the logs with the same base on the same side. Okay, so I'm going to bring this guy over here, I think, and I'll bring that guy over there. So I'll have log base 2 of 3 minus log base 2 of 24 equals negative log of 5 minus 2 log of x. Okay, so I just rearranged a little bit so that the same bases are on the same sides. Okay, and then I can combine. So this is going to be log base 2, 3 divided by 24. I can simplify that to 1 over 8, right? And then on this side, so, okay, be careful here, right? These are both negatives. So when you combine them together, right, this is going to be the log of, they both go in the bottom, right? Because they're both negatives, so they both end up in the bottom. So it'll be 5x squared, 1 over 5x squared. Ooh, fractions. Okay, well, what can I do from there? So log base 2 of 1 over 8, can I simplify that? Yeah, right? Log base 2 of 1 over 8. So we're saying 2 to what power gets you to 1 over 8? Well, you'd have to raise it to the third and then flip it, right? So this is negative 3. And now I can convert and solve. Remember, this is base 10. So I'm saying 10 to the negative 3 power equals 1 over 5x squared. Kind of annoying. I'm going to have to multiply both sides by 5x squared and then simplify this. So that's 1 over 1,000, right? And then we're multiplying it by 5. So if that's too much for you to hold in your head, right? So 10 to the negative third, right? And then we're multiplying that by 5x squared, right? So this is working out to 0.005 x squared equals 1. So 1 divided by that 0.005 is 200. So x squared equals 200. So then x is going to equal positive or negative 10 root 2. Negative log, still a problem. So one of those is extraneous, and it's just going to be 10 root 2. And there we go. Now, I didn't know it at the time, but see how we ended up with all these fractions, right? If I'd gone the other way, if instead of moving the two log base 2's over here, if I had brought this one over here and that one over here, it would have simplified it a little bit. You wouldn't have had these fractions to deal with, and it would have made your life a little bit easier. I didn't know it at the time, though, so I just had to go with what I had. But that happens sometimes. Sometimes going one direction will be easier than the other. All right, so there you have it. So things you want to watch out for, anything that'll simplify it, okay? If you only have 2 logs, then you can use that property and it makes it really easy, okay? If you have 2 logs and another number, as long as they have the same base, you can combine them together and then convert.